look at the top here. Okay, if for whatever, was anybody gone yesterday? Okay, so I'll put this back up here later. Okay, but remember that we started using the chart yesterday. Okay, to convert to get common bases. So if you don't have this, okay, I'll put it back up here. But if you do, will you pull it out from yesterday? So that we can just use it and not have to rewrite the whole thing?
Wait, so can we cross it out?
Well, I mean, if you want to. Okay, if you were gone, I'll just do it really quick. 4, 8. Okay, but I would just get out the one from yesterday unless you were gone. Okay?
We don't have to fill out the top.
If you have yesterday's, then no. You need to at least have one copy of it so that you have something to work off of. Okay, and then you won't need the bottom row on 6, 7, 8, or 9. Okay. So if you do not have those copied down, that's okay. I'll put it back up here. But the point is that we're going to be converting to get common bases to solve exponential equations. So I'm going to do maybe 1 or 2 like the ones we did yesterday just to get everybody on the same page. And then on the back, we're going to do extra properties. Okay, so your goal is to get a common base. Okay, remember the reason that you want to get a common base is because then the common bases can cancel. Okay, so after the common bases cancel, you can just set the exponents equal to each other, and then you're going to solve. Okay, compared to what we were doing before this with all the fractions and t-charts and everything, this should be super easy. Okay, so take a look. I'm not doing all of these because they're similar to yesterday, but if you take a look at number 2, okay, look at this side is a 16, so I would look up 16 as a base 4, 16 as a base 4 here. So I would convert that to be 4 to the 3x minus 5 is 4 to the 2. And then remember, the reason that I'm looking this up in the 4 column is because I want those 4's to match each other so that they can cross out. Now look, 16 is also in the 2 column, but that wouldn't have matched, that's why I don't pick that. Okay? Then from there, out of what's left over, you're going to solve. So it's 3x minus 5 equals 2. Drop your railroad tracks and solve. So if it's a minus 5, I would plus it across. 5 plus 2 gives me 7. Yep. Then divide by 3, and you get, as Yasser said, 7/3 is correct. Got it? Or 2, yeah, you can do it as a decimal if you like that better. Okay? Alright, let's do maybe 1 or 2 more. Next one we're going to look at is number 4. Okay, look at your base. On this side it's a 6, then this side needs to be a 6. What is 36 as a base 6? 6 squared. And then if you were here yesterday, we talked about, okay, whatever was already there, you have to group it. So if it was an x plus 3, I have to group it like that. Okay, then remember, the whole point of me getting a common base is that then I can slash them out. So my 6's here are gone. And then at the top, if I have a parentheses, I'm going to have to distribute or multiply.
I don't know how to do this.
Okay, that's okay. We'll practice it. Okay, so 2 times x is 2x.
Plus 6.
Okay, plus 6 equals 12. Because remember, I had 6's on both bases, so I crossed them out.
So minus 6.
Minus 6. Okay, so that gives me 6 left over, then divide by 2 is 3. Good. Make sense? Okay, let's do last one. 5. Okay, so look in your 10 chart. What is 1,000 as a 10 base?
10 squared.
Okay, so look at your chart. Thousands here, it's 10 to the third. Okay, so that's what the chart is for, is to check those. So I have 10 to the 8x minus 1 is 10 to the 3. And then once the 10s match, you slash them out. So 8x minus 1 is 3, add the 1 across, good. Bless you. Good, yep. 3 plus 1 gives me 4, then divide by 8. 4 divided by 8 is what?
4 8s.
Or you could put a half. It will put or
25.
a half. Okay? Does not matter which one of those you put. Okay, so turn over to the back. We're going to add some more exponent properties, but we're going to add them one at a time. The first one that we're going to look at is going to be the multiplication property for exponents. So do you guys remember when you were in algebra 1? Let's say you did this. X squared times x to the 5th. It is to the 7. Okay, this is why. Noel, can you turn around, please? Okay, x squared is x times x. X to the 5th is 1, 2, 3, 4, 5. So remember that when I multiply, I just add them up. That's x to the 7. So if you wanted to reduce this, you would do b to the m plus n. That's, okay, UB, are you talking on the phone during class? Are you talking to your own self? No. Okay, shh. Okay, so you're going to add the exponents at the top, okay? So if I'm doing this one, look at number 7. I have 9 to the x times 9 to the 2. Then I'm going to make it 9 to the x plus 2. Got it? Okay, and then 81 I have to convert. What's that?
9 squared.
9 squared. Then I have a common base of 9 on both sides, then I'm allowed to cross it out.
There's no solution or x equals 0.
Yeah, so x plus 2 equals 2. And then remember, the only way it's no solution is if x cancels out. So if I need to get rid of a plus 2, I'm allowed to minus 2 from 2. What's my answer?
X equals 0.
Good. And remember, 0 counts as a number. It's allowed to be the answer. Okay? All right, look at number 8 right next to it.
So it's technically not.
X, 3,
It is a solution, yeah.
3x plus 4.
3 to the x plus 4. And then on the other side, I need to convert 9. That's 3 to the
Squared.
2. Good.
Oh, that's easy.
Okay, then remember, once they match, you cross out the 3's.
X plus 4 equals 2. Minus 4 equals negative 2. X
Got
is
it.
negative 2.
Okay, so I subtract the plus 4 across. 2 minus 4 is negative 2.
So what about the next one?
Okay, so let's look at the next one. Now look at the third example. You have different bases. You have to make them all match. Okay, so look on your chart. What's 16 as a base for?
4 squared.
Okay, so that's 4 squared with an x already there. And then I have a 4 to the 1. And then look up 64.
4 to the 4, I think.
Nope. Third. Okay, and remember that that's where you just want to look at that chart. Now that I have all base 4s, I'm going to combine these guys together as 4 to the 2x plus 1. Questions about that are good? Okay, so since they both had a base 4, I'm adding the exponents together. And then I have 4 to the 3. Then from here it's the same. You cross out the 4s and then keep solving.
2x plus 1 equals 3.
Okay, good.
Minus 1 plus 1, 2x plus 2.
Okay, so I'll minus the 1 across from the 2x plus 1. I get 2x equals 3 minus 1, which is 2. Then divide by 2x is what? 1 is your answer. Good. Okay? Alright, now, if multiplying the bases, you add the exponents, what are you going to do when you divide the bases? Take a guess. You're going to minus. Very good. So, if you multiply the bases, you add the exponents. Well, then if you divide the bases, you subtract. So see how these b's are divided with each other? One is on top and one is on bottom. Okay? Now, it is important that you want to do the top first minus the bottom second. So if I'm doing this one, notice I already have 4's on both. So this is going to reduce to be 4 to the 2x minus 7. Now, why are they minus? Because they're divided. They're in a fraction. Now, on the other side, 64 has to come and match the 4s.
4 to the third.
4 to the third. Okay, and that's where you would use your chart. Okay? Then from here, the 4's cross out, and then you're solving as per the usual. Okay, so you'd have 2x minus 7.
Plus 7 plus 7.
Yep.
2 equals 10. So
Great,
2 equals
good.
5.
So if you need that step by step, you'd add your 7 across. That gives us a 10. And then if 2x is 10, we divide by 2 and you get 5. Okay? Alright, next one, how would it be set up for number 11?
That's 2x minus 5.
Good. X minus 5. And remember, the order matters. You have to do top first.
2 to the third.
That is 2 to the third. And remember, you're just using your chart on these. Okay? So I'd have 2 to the x minus 5 because they were divided equals 2 to the 3, which means x minus 5 is 3. What would my last step be there?
Add 5.
Good.
Is 8.
So x is 8. Perfect. Okay? Alright, number 12, you're going to have to convert it to make the bases match. So if the top is a 9, that's 3 to the
Squared.
2. So I would have to make this match this before I can use that rule. So that'd be 3 squared over 3 to the x.
Squared is 3 to the 2 minus x.
Okay, good. 3 to the 2 minus x. Now, on this one, be careful about your order. When I cross out,
Minus.
because they're divided.
Okay.
Versus like the top row, when they were multiplied together, that's when you add.
Okay.
Okay, so my 3's cross out. I have 2 minus x equals 7. How do I get rid of the 2? Minus it. 7 minus 2 is how many?
5.
So is x 5?
Is it negative x?
It's a negative 1x. Very good. And so if that's a minus 1x, I still have one more step. I have to divide by.
Negative 1.
And x is
Negative 5.
negative 5. Good.
I knew it.
Okay, number 13. I just want you to set it up. Would it be addition or subtraction?
Whoa, which one? 13? Addition?
Addition, and you would have to convert the 49 first.
7 squared.
Okay, good. So it'd be, and I'm not going to make you solve this one all the way out. I just want you to set it up. Okay, so you'd convert the 49 to a 7 squared, and then after you convert it, you'd make it x plus 2. Okay? And then from there, blah, blah, I guess, finish it. Or good. Okay, cross out the 7s. How would I get rid of the plus 2? Minus it across. What's 12 minus 2? 10.
2. It's simple like that?
Yep. Okay, now, the next one is like one that we did yesterday. So if you were here yesterday, we need to teach it to the people that weren't. Okay, on the left side, I have bases of 2's. What am I going to do with the exponents?
Add them. Subtract.
Subtract. So it'd be 2
Minus 3.
to the 2x minus 3. On the other side, it's a fraction.
Flip it.
Okay, but what do you have to do to the exponent when it's a fraction?
Negative.
Turn it negative. Okay, so look on your chart.
So 2 to the what? What? Negative 5?
It is 2 to the 5, but if it's a fraction, you have to use a negative exponent. So I'm going to make that 2 to the minus 5. Okay? So remember, 32 is 2 to the 5, but it's negative because it was 1 over that number. Then you'll cross these out, and then you'll solve. So if it's 2x minus 3, what would I do first to solve?
Add 3.
Add the 3. Negative 5 plus 3 is negative 2. Then divide by 2 is negative 1. Okay, the one other thing that we talked about yesterday that we did not have on this worksheet is when the answer has to be a 1. So look at your homework. Which one is your exponential equal to a 1? Number 3. Good. Okay, so at the top of your little chart here, I didn't fill it out for you, but anything to the 0 is a 1 right here. This is on your chart from your notes. So if I need a 1, I can use any base that I want as long as my exponent is a 0. So if I'm doing number 3,
3 to the 0?
it's 3 to the 2x plus 6, then I need to use 3 to the 0. Now, if this side was a 5, what would I use? 5 to the 0. So those bases have to match, but if it's a 1, then you're going to add in a 0 exponent on the base that you have on the other side. Okay? Okay, the only other one that we are going to do is number... I think it's on the back. Hang on one sec. Yeah, number 17. Actually, we really need to do 14 and 17. Okay, look at 14 first. Ignore the random box. I don't know what that is. Okay, it should just be this. 4 to the 2x times 4 equals 64. Okay, here's the problem. The second 4 doesn't have an exponent. What goes there if there's not a number there? Not 0. 1. So 4 is the same as 4 to the 1. Okay, and then from there, if I'm multiplying in the middle, what do I do with the exponents? Add. Okay, or plus. It'd be 2x plus 1, and then you'll convert 64. 4 to the third. Now, if you use your chart enough, you'll probably end up memorizing them all pretty much by accident, at least the important ones. So the 4's cross out.
2x equals 2, so x equals 1.
Yep. Okay, so I get 2x plus 1 equals 3, minus my 1 across. Perfect.
Is that the last one we done?
No, last one will be number 17. Get your chart out. I'll put my chart up here if you need it.
I need it. I don't need got nothing more on road.
Okay.
Wait.
Okay, number 17, I want you to look at your chart. Okay, I'll put this one back up here in a second. Okay, try to match up number 17 with a common base. Okay, what do you notice is the problem with number 17? Okay, is 32 in your 4 chart?
No.
Now look, 16 is, 32 is not. That means you can't use a base 4. You have to go to base 2. Okay, so if you can't use the smallest base, you may have to go smaller, and we did one like that yesterday. So when I convert, I'm going to put a little star here. I need to use base 2 because 32 isn't in the 4 chart. Okay, 32 is never a 4 base, then I can't use that. So I'm going to rewrite what is 4 as a base 2. 2 to the 2, 5x. Okay, then on the bottom I had a 32. What power is that? Nope. Okay, 32 is 2 to the 5th. And then on the other side I had a 16. That's 2 to the 4th. Gosh. Okay, 2 to the 4th. And then from there, now that they're all 2's,
You guys distribute.
now when I combine, will I add or subtract?
Minus.
I'm going to subtract because they're on top of each other. So it'd be 10x minus 5. Okay? Now notice you do have to times the 2 and the 5x. That's where the 10x came from. Okay? Then these guys cross out and you can solve. Okay? So 10x minus 5.
Plus 5.
Add the 5 across.
10x equals 9. 9 over 2. X equals 9.
So that gives me 10x equals 9. And then remember, I don't care particularly if you change it to a decimal or leave it. I'm going to just leave it. Okay, but 9 divided by 10, that's my answer. If you want to, you could put 0.9, but it does not make a difference to me which one you leave it as. Okay? Now, just to make it not confusing, will you change the title of your notes to notes 2? These should match each other. Okay, so right there. Okay? Alright, I'm going to leave 14 up there for another minute or so, and then I'm going to put the chart back up here. If you don't already have a filled-in chart, you're going to need one eventually. Huh?
Did you need 17? You said 14.
Well, I thought, does anybody still need 14?
It was me, but I didn't.
Oh, you're good? Okay. Yes, you may.
I need the chart.
Okay.